We start by declaring an inventory class. This is the single container that will keep your stock data and the methods that operate on it. The __init___ constructor runs when you create an inventory object, and here we use it to prepare the internal state so the object is ready to use immediately. We create self.items as an empty dictionary. Later we'll use item names as keys and quantities as values, which makes updates and lookups efficient. Next we define add_item, an interactive method you call when you want to put stock into the system. It asks for details and updates the dictionary accordingly. First we ask the user for the item name. That string becomes the dictionary key. Think of it as the label used throughout the program. Then we ask for the quantity and convert the input to an integer. Later you might add validation, but for now we assume the user types a valid number. This line either creates a new entry or increases the existing quantity by using get name 0. It's a concise add or create pattern that keeps the code tidy. We finish by printing a confirmation so the user receives immediate feedback about what changed. Feedback like this helps avoid confusion. The remove_item method lets the user delete an item entirely from inventory. We check existence first so the program behaves predictably. We prompt for the item name to remove. This should match the same naming used when items were added. Before deleting, we check if the item exists. This avoids runtime errors and allows us to give useful messages for both outcomes. If the item exists, we delete its entry from the dictionary so it no longer appears in lists or searches. A short confirmation is printed so the user knows the removal succeeded. If the item wasn't found, we handle that case separately rather than failing silently. This informs the user that nothing changed because the specified item doesn't exist in the inventory. Show_inventory is a read-only method that prints the current stock. Call it whenever you want a quick overview of what you have. We check for an empty dictionary first so we can give a friendly message instead of printing nothing and confusing the user. If there are no items, this explicit message makes the program stay clear to the user. If the inventory has items, we iterate over them and present each name and quantity. Looping over items gives us both the key and the value so we can print them together in a readable format. Each line shows the item name followed by its quantity, a straightforward way to present the inventory. Search_item asks for a name and then reports whether that item exists and, if so, how much of it you have. We request the item name from the user. Since it's the same key used elsewhere, the search will be consistent across methods. If the item exists in the dictionary, we print its stored quantity so the user gets immediate confirmation. This tells the user exactly how much of the found item is available, clear and actionable information. If the item isn't present, we inform the user so they can decide to add it. A plain message indicating the search came up empty. This encourages the user to add the item if needed. Outside the class, we define menu, which creates one inventory instance and provides an interactive loop so the user can manage items. Here we instantiate inventory so every menu action modifies the same object and you don't lose state between choices. We build a dictionary mapping user input strings to the methods we want to call. This keeps the loop clean and easy to extend. Option 1 is wired to the add_item method, so choosing it will prompt the user to add stock. Option 2 calls remove_item so the user can delete an entry if it's no longer needed. Option 3 prints the current inventory by calling show_inventory. Option 4 triggers search_item so the user can quickly check a single item's quantity. Option 5 maps to the built-in exit function, which stops the program when chosen. With this mapping in place, the main loop only needs to look up the user's selection and call the corresponding function. We use an infinite loop so the menu keeps showing after each action until the user explicitly exits. This is common in simple CLI apps. Each iteration starts by printing a menu header. \n adds a blank line to separate the menu visually from previous output. This prints the first menu option for adding items. This prints the second menu option for removing items. This prints the third option to display all items. This prints the fourth option to search for a specific item. This prints the fifth option, which exits the program. We read the user's menu selection as a string so it can be used to look up the corresponding action in the options dictionary. Using get returns the mapped function or none if the input is invalid, which lets us handle bad input gracefully. If action is not none, we call it. This keeps the main loop concise and delegates the work to the appropriate method. Calling action executes the chosen operation, add, remove, show, or search, on the same inventory instance. If the input didn't match any key in options, we reach this branch and let the user know they need to choose a valid number. This friendly error message prompts the user to try again without crashing the program. This standard guard ensures menu runs only when the file is executed directly, not when someone imports these classes into another module. Finally, we call menu to start the interactive inventory program so the user can begin adding, removing, and checking items.